Perfect. Thank you very much for confirming. Well, it's just about 11 o'clock. Allow me to bid you the official good morning or good afternoon, as might be the case for some of you. My name is Jean-François Bilodeau, or JF, whatever works best for you. I'll be presenting the Cloud Native Development and Application Modernization in Azure seminar. Couple of quick things before we get started with this session, just to get through the administrative portion of the session. If this is your first time using WebEx, I would invite you to familiarize yourself with the environment. Things like the raise your hand, so if you have any questions for me, so I can get to them. And I'll also be asking periodically throughout the session question, yes or no type of questions. So let's take advantage of that as we carry along. You can also type in question in the chat window at any time. I'll make sure to get to them as quickly as I can. We've got 2.5 hours to spend together. I want to make sure that we maximize our time when it comes to this session. The presentation is recorded, so if any of you want to review it after the case, or if you don't get a chance to stick around till the end, you want to view the end or you miss a portion, not a problem. You will be able to review this recording at any time following this session. So a couple of quick things before we jump right into this presentation. The goal of this presentation, this seminar over here, is to introduce you to, as we call it over here, Cloud Native Development. The idea over here is I want to take a on-prem application. I'll begin with a prototypical, reasonably trivial example over here of a web application. Not too trivial, but not too complex either. So the type of application that most of you would be familiar with, I would expect that some of you are developers, some of you might be architects, some of you might be operations. It doesn't really matter. We're maintaining those applications on-prem. Those applications includes on-premise resources, things like our databases would be a prime example, our servers, our VMs, our storage, whatever other type of resources that are used by the application. The goal of this over here is to look at ways to migrate those on-premise applications and take advantage of the cloud. So one of the things I want to get out of the way right now is the goal of this presentation is not to show you how to copy and paste your on-prem data center to the cloud. This is not cloud computing to begin with. That's offloading our infrastructure. So my goal over here is really to get you started with the cloud on the right foot. So we are going to focus on PaaS type of services, so platform as a service. We will not be getting into IaaS, infrastructure as a service, in this seminar, because once again, it is a component of the cloud, but I am of the opinion that IaaS, strictly using IaaS, is not cloud computing, and we can come back to that discussion later on if necessary. Another thing that I'm not going to get into is going to be SaaS, software as a service. The very reason over here is we are building a SaaS. In this demonstration that we are going to be doing, I will be taking an on-premise web application, migrating it to the cloud. And that web application is fundamentally a software as a service. The distinction over here is, if you want to think of it this way, our organization is offering that software as a service to our end user, be them internal, external, it doesn't really matter. So what we want to do over here is, again, not just copy and paste what we have on premise to the cloud. We could, and that's one migration strategy we could elect to use. But the approach I want to use for this seminar is jump the gun a little bit. Instead of going through a more step-by-step, piecemeal by piecemeal migration to the cloud, let's take a look at migrating the whole thing to the cloud and take advantage of the cloud. So the distinction over here is, if you were to do such a migration in your environment, you would do it piecemeal. I would not recommend a big bang approach, taking your big, massively complex web or native or mobile application and then flipping a switch and saying tomorrow everything runs to the cloud. That's a lot of work. That doesn't work. That implies a lot of risk. So if you are going to, as you are going to go through similar endeavors back at work, I would recommend do it piecemeal at a time. Now, emphasize where I would do those piecemeal changes through my cloud application. So let me introduce you to fundamentally what we're going to be using in this seminar, what I'll be demonstrating in this seminar. So again, I want to migrate at least one application, technically two applications, a web UI as well as a web API type of application to the cloud. That application will make use of course, website hosting, app services in Azure. We'll use SQL Database, so we'll use relational storage as we're using on-premise for the application, but then we will move into actual cloud computing. Let's get into things like storage, all right, not just having a disk drive over here, but or relational database, but let's get into blob storage. Let's also integrate that with our Azure search. Let's also integrate some of that with Azure functions. I like to demonstrate those for you as well. We're also going to move into security. Big important discussion, and that's a question that comes back very often to me as folks are moving towards the cloud. How can I ensure that my application are as secure in the cloud as they are on premise? All right, so let's talk a little bit about security, and I'd like to show you and propose a way by which, by taking advantage of the cloud, we can actually make our application more secure in different ways, depending on how your on-premise infrastructure is structured. So we're going to talk about Azure AD. We're also going to touch on Azure Key Vault, take advantage of those capabilities, and also hint at other approaches by which I can ensure that my application is written with security in mind and takes advantage of the added security that cloud can provide. So a lot of good things coming up for you. I do want to keep this as hands-on as possible. So I will be demonstrating concept. There's not a lot of slides over here. My goal is not to give you a slideshow, but to give you an actual demonstration. To get us started, let me show you where we're quote unquote at in our application. Now, you should be able to see my screen in the presentation right now. If you do not see Visual Studio right now within Adobe Connect or within WebEx, please let me know, or GoToWebinar, I should say. Please let me know so we can adjust this accordingly. Just taking a quick look at the question over here. All right, I've got a good question over here. I was just about to tackle this one. Are these Java-based or .NET-based application? That's a good question. I was just about to mention that for the sake of this presentation, I've elected to go the .NET route. But I could have easily gone the Java route, gone the Node.js route, gone the PHP route. Name your favorite web stack or name your favorite stack period. There's a good chance I could have run the exact same seminar no matter which stack you're using. I do want to emphasize that. I know if you come from a more traditional Microsoft background, you might think, oh, Microsoft Azure, obviously it is going to treat Microsoft technology as first-class citizen and alternative stack as second-class citizen. Well, I can guarantee you that much, it is not the case, and I can emphasize that using a number of approach. One of which is I am a Java developer before I'm a .NET developer. I've written a lot more code in Java than I've done in .NET, but Azure never stifled my capabilities when it comes to Java or PHP or Node. I do love my Node.js as well. So I'm actually using .NET over here simply for convenience, and I'll explain why as we carry along. It is not a development convenience. It was actually a presentation convenience. So going back to your question, it's a good question. No, it will not make a difference in terms of the presentation. The only thing that will change will be fundamentally the code and the ID. And of course, some of the APIs might be different. In terms of performance, if you're concerned about that, will .NET code run faster or better in the Azure cloud than Java code? No, there's no difference. All Azure APIs go through the same RESTful endpoint. So no matter which API you use, no matter which stack you use, you'll always be going through some RESTful endpoint in Azure, so the performance will be the same no matter which stack that you use. So the difference in performance will really be in terms of how you write your code, how you take advantage of your stack. There's another question over here on storage. What about the standard versus premium storage? Will that affect blob or other storage? keep your question in mind because I will come back to it as we discuss storage. There is a big difference between premium storage and standard storage, and I want to explore that one in more detail. I'm not going to go in tremendous detail in this session when it comes to storage capabilities in Azure. We could spend half a day on that just when it comes to storage, but I'll answer your question as we get to storage. So hold on to it. I'll answer it as quickly as we can. So I do appreciate your questions. Keep them coming, and I'll try to get to them as quickly as I can. Sometimes I might defer them till later on, but make sure to keep them coming. I'll do my best to answer them. So in terms of our application, just to give you a sense as to where we're standing right now, I'm using a sample application, the Contoso App Insurance, the insurance application over here. So it's a Microsoft demonstration code that I'm using over here. I'll show you where I can actually get it later on. But there's actually much more to this code base than I'm going to use in this presentation. Really, I'm going to focus on the website portion of this presentation. So the web UI, the application that our end user or fictional end users use directly from their web browser, and also a web API, set of APIs that our users, that the web UIs and other applications will use. There are other applications we could look at migrating to the cloud, but we're not going to have enough time in this presentation. We could look at migrating desktop application to the cloud. What we mean by this is our desktop application continue to run on the desktop, but now instead of connecting to our server backend, they use the Azure cloud. Same thing with mobile application. We could do the same over here with a mobile application, an Android or an iOS application that instead of using resources on premise or using resources on the device, would use resources within the Azure cloud. But the concept would remain the same. The APIs would be different. Some the programming model might vary a little bit, but when it comes to that, the concepts would remain the same. Got another great question over here. Wondering the consideration of Azure over AWS for SaaS. My specialization is Azure, but I've done my share of AWS as well. And I can tell you that being so competitive, the competition is so hot between the two that in terms of SaaS solution, they're pretty much equivalent. They're not truly the same. So what I do in Azure will not work in AWS. Same thing with what I do in AWS will not work in Azure, not work the same way, but they're equivalent. So if you're an AWS or a GCP or whatever other cloud stack that you're using, the demonstration that I'll be doing over here will of course be Azure focused, but the concept when it comes to migrating application from on-premise to the cloud will remain the same. The practices will remain the same. What will change will be the actual resources that I'm going to spawn in Azure. But the concept of infrastructure and the concept of services will be pretty much the same. So that's a really good question. Hold on to it because I will hint at it as we carry along. And again, I do want to emphasize that if Azure is not what you're using for cloud, or you want to extend it to AWS, GCP, or any other provider, the concepts are the same. When it comes to cloud computing, there's not 20 ways to do it. And again, being such a competitive market that we win out at the end, it means that if AWS comes out with a cool, new, exciting technology, you can bet that Microsoft will implement it very soon. And same thing, if Microsoft comes out with a cool, new, exciting technology, AWS will have it within a couple of days, couple of weeks, couple of months at the latest. All right, so that's a good question. Keep it in mind. Yes, my presentation will be Azure focused, but the concept will apply to any other cloud providers. So in a nutshell, here's my web application. I'm not going to run it just yet because I did make some changes to the code to prepare it for the cloud. So I wanted to accelerate things a little bit. Technically, it is no longer a native application, and I'll highlight why it's no longer a native application. I could hit the run button right now, but I've already included a couple of Azure calls in it that would cause it to fail. But nothing I want to bring to your attention. I also have a SQL database running locally on my machine over here, the Contoso Insurance Database. Nothing special about it. It's not designed to be an overly complex application, but complex enough to demonstrate migrating small, medium, or large application to the cloud. One of the last piece I'd like to show you over here that will be of interest for us is the application also stores a number of files, a number of PDF files over here, basically insurance claim that we need to be able to look up conveniently, want to be able to search, etc. So those right now are stored locally. You can see they're stored on my C drive presently. So that's something else over here I'd like to migrate to the cloud. So by the end of this session, I'd like to have pretty much every one of my local resources over here translated to the cloud, moved to the cloud, and be able to run the application from A to Z to the cloud. But more importantly, I want to do it in a way where I actually do take advantage of the cloud. And what I mean by this is, A, I don't carbon copy my on-premise infrastructure to the cloud. B, the other thing is, I'm not going to reinvent the wheel. I am going to take advantage of what we have, what the cloud has to offer. Things that on-premise might be less accessible, technology that would be less accessible to use on-premise. I'll demonstrate as we carry along. So that's the state of the application right now. So not a complex application. The goal of this seminar is not to get necessarily into the code. If you have any question on the code, hey, bring it up. I am a developer by trade, so I'll be more than happy to talk API and code and RESTful services. But again, the goal of that presentation is going to be more that translation over here to the cloud. So to get us started over here, let me log into Azure. So portal.azure.com. Again, if you're using an alternative provider, be it Amazon or Google or whoever else, not a problem. You can log into your environment. Whoops, my apologies. It might be in French. I'll switch it to English. And there we go. So my UI is in English over here. So here's my Azure portal. Now, for those of you who have never had a chance to work with Azure, no sweat at this point. I'll walk through some portion of the portal, but I'm not really going to explain everything about the portal over here. But again, if should you have any questions, please stop me. I'll be happy to discuss any facets of the portal with you. So within the portal, to get us started, what I'd like to provide over here is services that can host my application, all right? Services that can host my web application, that can host my storage, and also additional service I'd like to provide to my users. So let's keep this simple for now. I'm going to start by creating a new resource in Azure. Shouldn't take too long to come up. And from here, let me create a web application. Web application is the Azure name for a website. All right, there's a little bit more to it than that, but if you're wondering what they mean by a web application, be aware that a web application is really just a website in Azure. So the first thing I need to do over here is I need to give it a unique DNS name. Now, I know some of you probably already have the question or are probably wondering, what if I want to use my own domain name in the sense that right now, if I call it, let's say, Contoso, let's say insurance. Right now, I'm just going to try that. It's telling me, hey, the name Contoso Insurance is not available. It's a prefix to the Azure websites.net DNS name. So I need to choose a unique name. And again, I'm sure some of you are wondering, well, what if I want to use my own domain name, mycompany.com, whatever domain name I want to use? Not a problem. You can, but you will need to uniquely identify your application within Azure. So I'll use the name over here, Contoso Insurance JF. AzureWebsites.net. You will need to provide a subscription. In my case, I'll use my MSDN subscription over here. It's not going to cost me any penny. I'm just going to use some credits provided by Microsoft over here. Some of you with AWS, with GCP, with Azure may have an agreement, an enterprise licensing agreement for your cloud. Choose whatever would make sense as you're doing your migration. So in this case, I'll use my MSDN. Last thing over here, or next thing I should say, is a resource group. Now that's an Azure thing. There are equivalent in other environments, but a resource group, see it as a lifecycle or administrative boundary for your application, in the sense that a subscription can have as many resource groups as you want. Resource groups do not have any cost with them in Azure, so you can create hundreds of them. You're not going to incur a single penny. They're used for administrative or lifecycle boundary. What I mean by this is, from a lifecycle boundary perspective, you can use resource group to bring up or bring down or modify the structure of resources used by your application using infrastructure as code. So using code to define your infrastructure, what we call ARM templates in Azure. Using command line tool or even using the Azure Portal, I can define a template for my resource group and push that to my different server. A good example where this would apply is right now I'm using my developer subscription, Visual Studio Ultimate with MSDN. So if I am migrating one of our application, one of our on-premise application to the cloud, I don't want to do this live. I don't want to do this in prod. So what I might do is I might start to create the environment in a testing lab, a staging environment, doesn't really matter what it is, using typically a separate subscription for that. Set up my resource group over here. Once everything is up and running, it's golden, looks good, we're happy with it. What I can then do is grab the ARM template, and I'll show you how to do that later on. Grab that ARM template, push that to, let's say, my staging server, my prod server, it doesn't really matter, and rebuild the exact same environment in those subscriptions. And let's say as I push the application to prod, everything's good, we're happy. You guys have been in the industry long enough to realize that chances are we will have to make changes to the application, we'll have to maintain it, etc. So as I bring changes to my environment in my dev subscription over here, I update the ARM template, I add resources, modify resources, doesn't really matter what I do. I can then push those same modifications when I choose to my testing, staging, prod environment, however your environment is set up, without even having to bring down the existing environment. So resource group over here are used for application lifecycle boundary, as well as administrative boundary. And what I mean by this is I can conveniently choose who can administer what resources within that resource group. Or I can apply those permissions at the resource group level itself. I can choose an organizational unit and define that those have the role necessary to, let's say, create new resources or delete resources, whatever I want. So this is also used for administrative purposes in Azure. So what I'm going to do over here is I'll create a new resource group. I don't really have one created for this session, so I'll create one. Again, it's free. Create as many as you want. So let's call it Contoso-Insurance JF. That's just a name. Call it whatever you want. And the resource group, the names are bound to the subscription. So they do not have to be unique in Azure. They just have to be unique within your subscription. So use as many resource group as you see fit. In an example where you might have a lot of resource group would be in a dev environment. We have a dev subscription. We don't want to have 20 subscriptions for dev. We might have one simple dev subscription, many resource group for different development endeavor. Maybe in prod we'll have multiple subscription depending on how we choose to administer those, but in dev we might have numerous resource groups. So again, resource group are free. They're there to help you manage the lifecycle and the administration of your system. Resource groups do not add or remove capabilities to an application. What I mean by this is if I have, let's say, 3 resource group on my subscription and I publish, let's say, one application that is composed of different components in one resource group, or I publish the same application, different components of the application across different resource group, it will not affect the functionality of the application. Its capabilities will remain the same. So again, this is strictly lifecycle and administrative. So that said, I'm creating a web application over here. I gave it a name, a unique DNS name. Of course, if I wanted to, chances are I'll want to change it to a custom DNS name that I would choose something with my own domain name, mycompany.com or whatever. Resource group, because it doesn't exist, I'm creating it right now, but following this, I will be reusing that resource group. Moving down, Here we choose what operating system we want to use to host my web application. Being a .NET application, a natural fit would of course be Windows, but as most of you are probably aware, .NET has been ported to Linux, works excellent on Linux over here, so I could technically run it on Linux if I wanted to. But a big difference over here, it's not really the framework, but of course the operating system and by extension the web server we are going to be using. Choosing Windows, we're running IIS. Choosing Linux, we're running Apache. And for those of you who are taking advantage of Docker, there it is right there. It's not the only Docker integration with Azure. Azure has first-class Docker integration, but right off the bat, I can create Docker instances to host my website instead of a dedicated VM to host IIS or to host Apache. So in my case, I'll stick with Windows. All right, but again, I could as easily switch to Linux if I wanted to. And again, just to highlight the difference between, say, the Microsoft of 10 years ago and the Microsoft of today, Linux is not just a first-class citizen in Azure, but there are some places actually in Azure where Linux is favored over Windows. And if I can even share a little something with you, talking to some folks coming from Microsoft over here, I almost get a sense that they're proud to announce how strong and solid their support of Linux is, and how in some cases Linux support even trumps Windows support. I'll give you examples of that. I'm not trying to get into Linux versus Windows discussion over here, but I do want you to realize that it doesn't matter which operating system you come from, we've got the best of both worlds over here. And again, as a developer, I do love my Docker. There it is, strictly for web hosting. But if you want even more generic Docker, you want to use your Kubernetes services in Azure, they're there for you. So to move ahead, the next thing I should create over here is a service plan, which basically indicates the amount of resources I want Azure to throw at my web application. Azure here is proposing to create a new de facto resource service plan. I'm going to create one from the ground up over here. I don't like the name. It's going to be hard to maintain long run. It's going to put it in central US. That's not where I am. So I'm going to create a new service plan over here. You give it a name. That's a name that's unique to your subscription. So I'll call it, say, JF App Plan. That's just a name. Call it whatever you want. Where should we host this application? Well, I'll move that to, say, Canada Central. That's Toronto City. We've got two data centers in Canada, Canada Central and Canada East, which would be Quebec City. Eventually, we're going to get additional data centers in Canada, but these are the two that are offered for us right now. And the last thing I need to choose over here is the pricing tier, which determines how much resources will I be using over here. Oh, I'm seeing a question over here. Will you add a version number in the resource group to track version? Honestly, no. I would not. I would advise actually against renaming your resource group, versioning your resource group. One, the reason is different components of your application may be updated out of band. It's very rare today that an application comes out as a single unit, usually gets updated as different components, more of a DevOps-ish approach. Second thing is renaming resource group over here will break script, will break automation, will break the very functionality behind ARM template. So no, I would not recommend that you rename your resource group. Don't use them for versioning. If you want to version something, do it at the source code level, do it at the package level, not at the resource group. So that's a good question. I'm glad you asked, Denise, but I would strongly advise against that. That's not what they're designed for. They have no intrinsic versioning capability, nor do they need them. So back to the tiers I want to use for my web application. Now, again, we could spend some time on this. There's a lot of options available for me over here. And for those of you after this session who want to play around with Azure or GCP or any other stack, doesn't really matter. You've got different options which give you different capability, different amount of computation and memory available to the running of your website, as well as capabilities. Again, we could spend some time on that. Well, I'll start with something pretty straightforward. I'll start with an S1 standard one over here, which will give me one core, dedicated CPU for this one. Actually, this one might be a shared CPU. Almost 2 gigs of RAM should be adequate for what I want. So it's an A series compute. If you're not sure what those are, look it up on the web. You'll find that pretty quickly. And an estimate as to how much it would cost me per month to run my website through that. This is, of course, an estimate. It is a cloud resource. You pay for what you use, all right? So it may end up being less, may end up being more, depending on how much of the resource is being used. An S1 does include some cool feature, custom domain, all right? So for those of you who want to rename this to contosoinsurance.mycompany.com, I can do that. If I go to a dev test, for example, and I choose a shared infrastructure, I'm going to get, well, an infrastructure that is free, not a lot of capabilities, nor do I have the ability to give it a custom domain name. I also have the ability to auto-scale this application, where using either calendar or usage metric, I can indicate to Azure to increase or decrease the number of instances to provide to my user. And this one gives me a maximum of 10 instances available for my user. So in other words, I could have it scaled down to maybe a minimum of 3 when it's not very busy. Let's say the CPU or the RAM is not very high, but as the CPU or the RAM or the bandwidth, the HTTP queue starts to fill up, I can have Azure automatically add instances and remove them once the usage goes down. Another cool feature I want to highlight for you, I'm probably not going to demonstrate this one though, staging slot. You're probably familiar with the concept of staging slot, but using other names depending on the infrastructure that you use. Staging slot allows me over here to publish up to 5, let's call them versions of the application. It is not a versioning capability over here, but 5 slots in which the application can run and flip between which slot is currently used in production. Only one of those can be used in production at a time. And the idea over here is, let's say I'm publishing my initial version of my application, it's in slot 1. I'm making an update to the application, updating the code, pass it through testing, pass it through staging, it's ready to go in prod. What I would do over here is publish it to slot 2. Slot 1 is still active. When a user hits my website, they hit the website in slot 1, they don't see the update just yet. Using a special URL, I can actually connect to the website on slot 2 and test it. Make sure that everything looks good, it's working fine in prod, and if everything looks good, I can then just flip the slots, boom, slot 2 now comes into production, slot 1 now goes behind the scene, any subsequent HTTP request ends up with a new version of the application. So completely transparent at this point, no downtime for the application. And because slot 1 is still there behind the scene, if we realize that there is a problem with the application, something that we've missed, I can, at the click of a button, flip back to slot 1, bring back the old version of the application. Question over here, can you revisit choose a data center? You can actually pick a geolocation of cloud. Yes, you can. And actually you need to for a couple of reasons, one of which is legislation. Since you are running code and possibly processing folks' data, you need to ensure that this is going to be processed in a country, in whatever countries you want to permit that. As an example over here, a lot of the work that I do, I'm from Ottawa myself, a lot of the work that I do is with the federal government. One big key concern for them is if they are going to be processing data using Azure or AWS or any other cloud provider, they want to make sure that the data remains in Canada. We don't want Azure to magically send data to, let's say, the US or to Europe or to Asia, or run the code outside of the country. So when it comes to that, yes, you choose which data center your code runs into or which data center holds your data. And the idea over here is you're guaranteed that unless you do so, your data does not escape that data center. So when it comes to that, I'm hoping that this helps answer the question of why we had to choose a geographic location for the cloud. The cloud over here, we should not see it as this nebulous entity that encircles the globe, but as a nebulous set of resources that we can use to run our application, that we can spawn on demand to run our application, but we still have the ability to choose where those resources physically exist, at least within the country. Another question. Isolation look interesting. Can you share info? When we're talking about isolation, I'm not sure where you might have seen that, but we're talking about whether or not the CPU, the IIS instance or the Apache instance would be shared by other web app. So by isolation, fundamentally what we mean is, do you have a dedicated machine to run your website or not? If you have a dedicated machine, you fundamentally have a VM managed for you by Microsoft. Could be Windows, could be Linux, could be Docker if you wanted to, and that CPU, that RAM is dedicated to your application. No other application will be able to impact its performance. In a shared instance, the difference over here is it's still running in a VM, it is still managed by Microsoft, but more than one application might be using that same instance. Now, the applications will never see each other. So if you're concerned about your data being seen by another application, it ain't gonna happen, all right? They run in isolation. If you're concerned about somebody's CPU, somebody starving the CPU from your application, that also is not going to happen. It's running within a VM, and the CPUs are tightly controlled to ensure that you're guaranteed, as is the case over here, I'm guaranteed one core of CPU over here, running at so many megahertz over here. The distinction over here is because it is a shared instance, if the site is unused, Microsoft Azure may elect to bring down the site since it's not using CPU, bring it down and then install another shared site in that VM. If somebody goes and visits your sites again, well, then Azure will again bring back up your site, but it may bring it up in a different instance somewhere else in Azure. So the caveat that you have with a shared instance is going to be that that period of typically 30 minutes of inactivity, where if your site is not used, Azure may bring down your site and then resurrect it the first time it's called on a different machine. That's the caveat. An advantage to a shared instance, though, as opposed to a dedicated instance, is that a shared instance, you only pay for what you use. Dedicated instance, you're going to pay for that instance 24/7. It is dedicated to your website. Nobody else is going to use it, so it will cost you a little bit more, but you're not going to have your website's not going to go up and down, up and down, up and down if it goes unused for 30 minutes or so. So I'm hoping that this helps answer the question over here related to shared instances. There was another question. Let me just bring that up a little bit. Are auto scaling depending on the same scaling as prod slot? Only the production slot has scaling enabled. The other slots, you can connect to them directly, but you'll only have one test instance available for you, which will not scale. So scaling is only related to production slots. So I'm hoping that this helps answer the question. Not a problem. And to continue with the point of data location, would it also be worth going over the difference in locality geo-redundant storage? That's a good question. It was my understanding that geo-redundant storage also would need to be monitored to ensure what data center the data stays at, but it might be wrong. Yes and no. Hold on to that question, Brady, because I will come back to that discussion when I get into data storage. All right, it's a great question over here, and we'll talk about how replication takes place in the world of Azure. All right, so again, great question, hold on to it. And you guys are asking a lot of good questions. I do appreciate it. Please keep it up. Just going to wrap up the creation of my website over here. If more questions come up, hey, not a problem. I will use a standard tier over here. Apply. So here I've created my service plan. This service plan I will be able to use and share amongst other web applications should I choose to. For example, my API service, which I'll talk about later on. So I gave it a name. I chose a location for it, Canada Central. That's for the service plan itself and the pricing tier. Sorry, I should mention the location that I've selected over here is where that service plan is stored, not where the site will run. When I create the site, I will choose its location. I'll demonstrate that as we carry along. And then the pricing tier, we've discussed that already. Let me click OK. And there we go. So I've got my web app that's almost ready to be created. I gave it a name, chose a subscription for it, created a resource group. From this point forward, I'll actually reuse that resource group. I want to keep all the resources for that application together and the application service plan. I'm not going to use application insight. If you're Windows or a .NET developer yourself, chances are you're already familiar with application insight. It's fundamentally a mechanism by which I can get deep debugging insight for an application. It allows me to connect, for example, my Visual Studio or my Eclipse, my IntelliJ directly to Azure and get that deep insight that App Insight provides when I'm debugging my application. It adds a little bit of overhead to the execution of my application, plus I'm not going to use that in that demonstration, so I'll leave it off for now. Before I click OK, I just want to highlight for you automation options. For those of you who are new to Azure, here's where we're getting into infrastructure as code, a very important concept of DevOps over here, where our infrastructure is not defined by, let's say, a Word document or a Visio document describing how all the different components fit together, and that's probably 20 versions out of date anyway. Instead, with Azure, our infrastructure is defined using what we call ARM template, Azure Resource Manager template. We can see over here Azure Resource Manager template. So if you see mention of ARM template, that's what we are referring to over here. An ARM template is a combination of two JSON file. The template itself, which describes, I'll just highlight for you where it describes, there it goes. This template describes a site. An ARM template can define as many resources as you want, but this one really has only one thing, which is a site, the name of the site, which is parameterizable. We can come back to that. Hosting environment, we're going to use Windows for that one, but again, it comes from parameter. Where is it going to be hosted? Again, that's going to come from a parameter. The parameters for the template comes from a separate file, still a JSON file that we can see over here that contains the value for that template. And the idea now is I can push that same template to different environments. And if I need to adapt the template to the environment, I don't have to change the actual template. This one is static. What I change over here are the parameter. I can change, for example, the name of the site, the application, the hosting plan I want to use, where do I want to run the application? We hinted at that just a moment ago, etc. So this gives me the ability to define my entire application infrastructure from the very simple to the heavily complex entirely using code. So very important capability over here of the web, of the cloud that we're looking at over here. So I'm not going to spend really a lot of time on ARM template, but I did want to highlight that for you so I could download those templates. Oh, and by the way, to apply the template, to move it to a different, let's say a different subscription, to apply it in a different subscription, I've got a couple of choices. I can download it and upload it in a different subscription using the portal. Or I can use command line tool. Here's a bash script, so a Unix script over here, Linux script, that would push that ARM template to whatever Azure instance you want to use. I could also use PowerShell. So if I'm running more of a Windows shop, there you go, I would use a PowerShell script to do the same. Here's an example as to how I could push it using C# code. Same idea, except this time it would be in code. So for the programmers in the classroom over here, if you come from programming background, .NET, Ruby, I could even do the same in Java, but there's no Java template generator just yet. I could write that code to automate the management of my resources using whatever programming language I want to use. Name your favorite programming language. There's a good chance it's supported first-class citizen in Azure by Microsoft. And if it's not supported directly by Microsoft, there's a good chance that the vendor of the programming language or the community around it has built API for Azure. And again, I'm speaking from experience over here, so not just theory, but actual practice. And for the systems administrators in the classroom, you're more accustomed to scripting. You like to do your PowerShell script. You like to do your bash script to automate tasks. Again, you've got script templates that you can use that will work out the box for you. Question, is it recommended to managers to manage all our templates in the Git repo and version them? Absolutely. I'm glad you asked. From a DevOps perspective, that's essential. So will future change by Microsoft render my template obsolete? No. All right. And Microsoft, I wouldn't say they learned the hard way, but it was a conscious decision that they've done about 5 years ago now, maybe 6 years ago now, where before we had ARM template, they had the classic resource management available to us, which was anemic compared to what we had over here. But Microsoft was just getting into the cloud business. They did not, and I'm not speaking against Microsoft. I mean, they were very late entrant into the cloud business over here. Their first go at Azure wasn't as solid as they could have been. So what they've actually elected to do over here is drop, I wouldn't say drop, but really create almost two versions of Azure, a classic version of Azure and a new version of Azure, the ARM version of Azure over here, which caused a schism, if you want, in the Azure world, where all the templates or all the scripts that you might have written with classic Azure no longer work with the new Azure. Classic Azure is still supported in most data centers, right? For example, you're not going to see much classic Azure in the Canadian data centers because they opened up about 2 years ago, long after ARM resource template were available over here. So going back to your question, will Microsoft break compatibility? Well, Microsoft already had to break compatibility once to bring us ARM templates over here. They are not going to break compatibility again because now there's Microsoft and their clients are so heavily invested into that they would lose 3/4 of their clientele at this point, right? So when it comes to your question, yes, it is stable. It is not going to change. They will continue to add to it, but it will be backwards compatible. Is Python and Go supported in Azure? Absolutely. Actually, if I can give you guys a big hint over here, you're probably aware that Microsoft actually bought GitHub, which is the largest code repository, open source code repository on the internet today. Microsoft, one of the reasons why they bought GitHub is that every library that Microsoft offers today, not just Azure, but most of their products today are open source and they're all hosted on GitHub. So as an example, somebody asked, is Python supported for Azure? I'm going to go to GitHub over here, do a search for Azure Python. It brings me over here to the Python SDK for Azure, and this one is provided by Microsoft. So it's not a third-party tool over here. It is written provided by Microsoft. It is developed using a community approach. It is maintained up to date. I mean, I'm looking at the commit over here 6 days ago for 7 days ago. So it is maintained up to date, and it is developed by folks who know their Python, right? And I can speak for most of the SDKs since I've used a lot of those. There, in the case of the Python SDK, it is Pythonic. All right, if you're asking about Python, you're probably familiar with that adjective. So it is Pythonic. It's not .NET-ish. It's not Microsoft-ish. It is Pythonic. I want to get the SDK for, well, what's the other one? Go. So Azure Go. Guess what? Oops, I searched in the wrong repository. Let's go to all of GitHub. There we go, Azure SDK for Go, again, provided by Microsoft. So again, name just about any reasonably widely used programming language out there. You've got first-class support for that language over here from Microsoft. It's not a third-party tool, but it's from Microsoft. And if you do happen to use a programming language that is not supported by Microsoft directly, let me give you an example over here. Amongst my many programming language, one that I've been using for over 2 decades and I still love is good old Delphi. Do we have Azure support for Delphi? Azure Delphi? Read that, could not find any code matching Azure Delphi. There is none. For whatever reason, Microsoft hasn't created an SDK for that. Well, 2 things to know about that. A, Embarcadero, the company that owns Delphi, does have their own Azure SDK. that comes with Delphi. All right. So if I want to do some Azure work with Delphi, I can use their SDK. But I'll be honest with you, their SDK is not complete. There's some capabilities that I like to use in Azure that are not directly supported by Delphi. Not a problem. Here's what I do. Azure REST API. And there you go. The Azure REST API reference. Every API that is available to you in Azure. Doesn't matter what you want to do, whether it's, well, we'll talk a little bit about app service. We can talk automation. We can talk billing, content delivery network, compute. All right, take a look at all the resources that we have over here. Every single API libraries that I hinted at on GitHub are all use the same RESTful endpoint. Whether it's .NET or Java or Python or whatever you want to use in here, they all use the same RESTful endpoint. Those endpoints are actually fully documented over here in Azure. And again, I can speak from experience, having done that in the past. If I need to use an Azure capability that for whatever reason is not supported in my favorite programming language, whatever programming language I'm expected to use for that project, well, in that case, not a problem. I just issue straight RESTful requests. And again, I can speak from experience. I've done code to do that numerous times in the past. And it's fully documented. This is a Microsoft site, so this is not a third-party site. So Microsoft fully documents all their APIs over here, right? So it doesn't matter what programming language you use. It's not going to be treated as a second-class citizen, since every programming language, every stack goes through the same set of RESTful requests. You search for Delphi. Okay, thank you very much. My mistake. So let's try all of GitHub. And there's a couple more. I was kind of surprised to see none, but I do want to highlight that there are none directly from Microsoft, but there are a couple of third-party ones. I haven't really used them, so I can't really comment on those, but there's one, for example, the Azure Data Lake Store for Delphi. I actually looked at it in the past because I was considering using it for a project not too long ago, but there's none directly from Microsoft. So thanks for that catch over here. It wasn't intentional, but again, I do want to emphasize that there's none from Microsoft just yet. So this is more the exception than the norm, and one of the reasons why that's an exception is that Delphi is not, though it is a very widely used programming language, it's a single vendor solution, right? There's no open source version of Delphi. There's no ISO version of Delphi. Hence one of the reasons why Microsoft does not support it directly, because Embarcadero is supporting it for them. So that said, again, you guys are asking a lot of good questions. Back to the ARM templates in Azure. I'm not going to do anything with the ARM template, but I did want to emphasize how we do infrastructure as code in Azure. But I will come back to that later on. Let me wrap up that first part of the demo over here, the creation of my web app. I'm almost done. Create. Shouldn't take too long. It's a very light resource to create. Validation successful. Deployment in progress. We can see over here in the notification icon, it's spinning over here, indicating that something is happening. And while that's happening, again, it should not take terribly long. So while this is happening, the next resource I'd like to create, I'm not going to wait for that to finish. I don't need to wait for it. The next thing I want to do over here is transfer my SQL on-premise SQL database to the cloud. Now, this one might warrant some discussion. Migrating a web application to the cloud, generally that's pretty trivial, right? There's not 20 variants as to how you're going to manage a web server, right? Be it IIS or Apache or Tomcat, by the way, which is also available in Azure. You also have support for Jetty in Azure. And for the Java developers in the seminar, if you need to host WebSphere, WebLogic, Wildfly, these are all supported, but via third-party resources in Azure, right? I'm not going to use those in that demonstration, but just a little FYI. So when it comes to hosting a web application, there's again not many variants as to how you're going to configure a web server. In the case of relational storage, whether you're talking about say Oracle RDBMS, Microsoft SQL Server, MySQL, or Postgres, or whatever database you want to use, now there can be a lot of variance, right? And also when it comes to hosting a database in the cloud, there are advantages. There's also caveats I'd like you to be aware of, and we'll discuss those as we carry along. But here's the first thing I'd like to suggest, and I know that may not be a capability or an option for everybody in the seminar, but do you need a relational database? Right? Something to consider as you're migrating your application to the cloud, or especially if you're starting development for the cloud. What I mean by that is for on-premise application. It's almost a knee-jerk reaction today. We need to create an enterprise application. We need to host it on our server. We need to store information. We'll put it in our database. All right? That's the way we've been doing it for decades. And I'm not saying that this is a wrong approach, but because we are moving to the cloud, we can move to alternative storage approaches. SQL Database are supported, all right? And I will play around with SQL Database very soon with you, but we also have NoSQL database that are also supported. We've got CosmoDB, which is a very, very powerful database which supports fully distributed graph-based or document-based storage, or pretty much whatever type of storage that you want to use, with multiple ways of querying it, support for SDKs for most programming languages that we hinted at previously. So I would strongly recommend, for those of you who want to get serious about the cloud, take a look at alternative storage. All right, relational storage is one approach, and we're so accustomed to thinking in a relational storage manner that moving to a NoSQL type of database will be a change in the way we think about a storage, a change in the way we think about our data, but this is something I would strongly advise you to take a look at. Now, unfortunately, in this demonstration, I'm not going to have the time to really get into that, but again, I do, since we are talking about migrating application to the cloud, as a first step, let's try not to change anything. Let's try to just grab the application as is with little to no modification, move it to the cloud. And after we've accomplished that, then let's talk about maybe using other cloud capabilities, including NoSQL storage. And I would strongly encourage you to do that as well. So what I'll do over here is, for my Contoso application, let me create a new SQL database. And actually, I clicked on the SQL database. I'll use the more traditional route, create a resource, and I'll create a SQL database over here. Now, SQL database is fundamentally SQL Server as a service. For those of you who have some experience with Microsoft SQL Server, you'll feel quite at home over here. If you've never used SQL Server, hey, not a problem. If you've used MySQL, you've used Oracle RDBMS, you've used whatever other database out there, you'll recognize the principle. The important part over here is I'll actually create two resources, not one. The first resource that I'll create will be, well, the database itself, but the database needs to be hosted on a server. So that's the second resource I'll create over here. Actually, I should flip them around. I'll first need to create a server to host the database, but I'll do them in one go. I'll begin by creating the database. So I need a name for my database, and that's a name that I choose that has to be unique to the server. So I'll call this database Contoso Insurance. That should be good for now. Subscription, I'll leave that as is. Resource group, because it is related to my Contoso Insurance application, I'll put that in the same resource group. All right, this will allow me to manage every component of that application as a unified whole instead of as individual resources. Select source, optionally, I could load a sample database or restore the database from a backup. I'm going to do a blank. Moving ahead, server. I need to either select an existing server. I happen to have one over here that I've used for a previous demonstration. In my case, I'll create a new server, just to quickly highlight some of its capabilities. So here, fundamentally, again, for those of you who know your SQL Server, I am creating a server instance over here, right? It is fully managed by Microsoft. It runs in a VM. I'm not going to be able to touch it, but everything, pretty much anything I can do with my SQL on-premise, I will be able to do in the cloud, and I'll highlight that for you. The first thing I'll need to do is I'll need to give it a DNS prefix to database.windows.net. And let's try Contoso Insurance JF. Green check mark, it's unique. Had it not been unique, let's try Contoso Insurance. Boom, this one fails. The name's already in use. All right. As a little FYI, I'm using English-ish name over here. A lot of organizations use some kind of naming convention that could include maybe even GUIs or randomly generated value, timestamps, that sort of thing when it comes to creating those resources. I'm not going to advocate any approach versus another. The only thing I'm going to strongly encourage you guys is, as you're migrating to the cloud, as you're exploring the set of resources that it can create, have a convention for your organization. Make sure that we name things consistently so we can find our way through the umpteenth amount of resources that we have on our system. I'll need to provide a login name. All right, so I'll create a login. I cannot use things that are too obvious. All right, for a security reason, if I try to use something like SA, it's going to complain. All right, that's not the password, but the actual account. There you go. Your login name meets the following requirement, and is not a typical name like administrator or admin or SA root. None of those are permissible. So it's going to be something that will be a little bit harder to guess. Mine's not going to be too hard to guess, but I'll use JF Bilodeau. Password. Let me enter a top secret password over here. Yeah, man. There we go. And very important, where do I want to host that database? Where should the data exist? And I'm going to pick again Canada Central. And going back to our previous discussion, this is important over here. I want to make sure that, well, dealing with insurance data for legal reasons, I can't allow that data to fly all over the world. I want to constrain it to Canada. So this will ensure that it remains in Canada. I know there was questions about replication. We'll come back to that later on. I'm not going to use replication. So what I've done over here is I've created a database server. Well, I haven't actually created it, but I've provided the values to create the database server. So here's the server information I like to create. I'm not going to worry about the elastic spool. Pricing tier. How much hardware capability do you want to throw at your database? The way that Azure does this is via what we call DTUs, Data Transaction Unit. If you want to know more about what those are, click on that link. It'll bring you to a very detailed page explaining to you what are DTUs. Whoops, let's bring that in English. Boom. And there you go. Here's what DTUs are. I'm not going to spend time on that, but again, that explains how Azure manages and treats what we call DTUs. So I'm going to go with actually a very basic workload over here. This is more of a development testing environment I'm building over here, not a prod environment. So I'll start with a basic 5 DTU over here. That will be adequate, but it will limit my database size to 2 gigabytes, which for prod probably won't be big enough. By going to standard, I can increase my DTUs over here, and I can increase up to 1 terabyte. And if 1 terabyte is still not enough, I recognize that in a especially well-established organization, we generate data very quickly, or we have a lot of history. So you may want to go to premium, and at this point, we can scale up to 4 terabyte over here of size, right? But that's the maximum size we can hit with a relational database. If you need to go above 4 terabyte, you're thinking, hey, I want to be able to go into the petabytes. Again, no SQL type of storage. Cosmos DB type of storage, Hadoop data lake store, those type of technology in Azure will allow you to store petabytes worth of information. I've worked with some organizations that have taken advantage of that, where they have hundreds of terabytes, if not petabytes worth of information stored safely in Azure. Something else I'll mention right now, let me just go back to basics. Yeah, leave it as is. Something else I'd like to mention is that everything you store in Azure is guaranteed to be at a minimum triply redundant, right? You've always got a mirror of the data. So this is managed for you by Microsoft. You don't see that, but you've got a mirror of your data plus a third redundant copy zone that is stored in a different zone, so that if in the mirror set, let's say a rack goes down or even a building goes down for Azure, you still have a third redundant copy available for you. So if that device goes down for whatever reason, the infrastructure automatically rebuilds the mirror for you. There's not even any human intervention required for that. All that Microsoft gets is a notification in their log that this rack fell and might have been replaced in a fully automated fashion. Pretty much all the Azure sites are fully automated. There's very, very little need for human intervention when it comes to that, right? So this is the lowest level of data integrity you can have in Azure. If you need something higher, you can. If you decide 3 redundant copies is too much for me, you can go any lower than that. Nor is there any need, it's automated, right? That's the way it's managed for you in Azure. So let me select over here a basic size for my database. So a limit of 2 gigs, but will be enough for this demonstration. And collation, I'll leave it as Latin 1 over here. So Western European encoding. Let me create 2 things, both the database server and the database on the database server itself. So those 2 resources are being created right now. I've got deployment in process. While that's happening, I'm seeing there's a question, what is DTU? Data terabyte units, actually data, a data transaction unit over here. And I think I should have it somewhere in here. Trying to look for the actual description of the, there we go, data transaction unit. That's what DTU stands for. So I'm hoping that this answers your question. And again, you guys are asking a lot of good questions. I do appreciate it. So I've created my database server. On that database server, I've created a database. It's ready to roll. Well, it's almost ready to roll. It is still being created right now. I've got my deployment in process. Ooh, that's taking a little bit longer than I like. 13 minutes. Ooh. Kind of concerned about that. Just want to see where we're at. I'm looking at my resources. I can go into my resource group. Let's do that for now. Go to my Conto, so Insurance JF, and here I'll see a list of all the resources in that resource group. There's my database server, SQL Server, but my website is taking longer than I'd like. That's not what I want to do. Longer than I'd like to create. If necessary, I'll quickly recreate it. Is the collation for the SQL instance or the database? It's for the instance. All right, I'm assuming that answers your question. Again, if you have further questions, let me know. All right, so while the database itself is being created, there's one more resource that I'd like to create, but I want to come back to the database itself. I want to demonstrate some capabilities. But before we do that, let me create a storage account for my application. I will use the storage account for its probably simplest use. Oh, there we go. Database has been created, which will be to host files, to host the set of files that we have over here, those PDF documents. And later on, I do want to make them searchable, so I want to index them. So we'll come back to that. So moving ahead, let's create yet again another resource over here. So that will bring us into another very important discussion: storage. So I want to create a storage account. What is a storage account in Azure? A storage account by itself does not store anything. A storage account is more for administrative use, reporting use, billing, however you want to define it. Could be for the application as well. Actually, it will be for the application as well. A storage account will contain one or more containers. Right? Those containers is where the information actually exists. But the storage account by itself doesn't store anything. Under the storage account, we've got containers. So to create a storage account, I will need to, again, provide a DNX prefix for core.windows.net. Let's call this Conto, so Insurance JF. Boom, it's available. Again, it has to be unique. And storage accounts are not meant to be user usable. All right, so you would not send a user directly to contoso.insurance.core.windows.net. So when it comes to the URI, the domain name that we use over here, it's less important to have something that is branded at this point. What's important is that the application can connect to it. So when it comes to storage account, typically we don't worry about using providing custom DNS name. So moving down, deployment model, I talked about that previously, resource manager versus classic. There is no need today to go with classic. Go with resource manager. All right, classic has been deprecated for 5-6 years now. It is heavily restrictive compared to what we have in a resource manager. Does not support infrastructure as code. Microsoft is no longer developing classic. It is strictly there to support existing application. So unless your organization, your team is maintaining an old, I'm going to say legacy Azure application, don't go with classic. Go with resource manager. End of story. Storage count. I had a question over here about premium storage versus regular storage, and now I can start to access, actually there's the performance down below, but be aware that there's different type of storage in Azure available for you. There's general purpose V1, V2 that's available for us, and blob storage. Blob storage will use that, but I'm going to create actually a general purpose V1 storage. So what is the difference between V1 and V2? Without going into the detail, one important and interesting difference between the two, V1, individual blobs, files that you're going to store in the storage account are limited to 1 terabyte. V2, they're limited to 4 terabytes. Now, if that limitation sounds familiar to you, remember that when we were talking about database, I've shown you that using standard, I'm limited to 1 terabyte. What a coincidence. Then if I go to premium, I can scale up to 4 terabyte maximum. Interesting coincidence again. Well, it is not a coincidence. What's happening over here is in Azure, fundamentally anything that needs to be stored is stored in a storage account, whether it's a file that you want to provide your user, whether it's simple NoSQL database, whether it's an actual SQL Server database you want to store, whether it's a file system you want to expose via a Samba share, whether it's a VHD file, virtual hard disk files to run the Hyper-V that you want to store in Azure, they're all stored in storage account. So that's why very often in Azure you will see a limitation in size of individual files to be 1 or 4 terabyte, depending on whether we use general purpose V1 or V2. In my case, here we go. Might as well go with general purpose V2, take advantage of the latest and greatest. Very important, where do I want to store that information? All right, and again, I want to make sure that because I'm going to store sensitive insurance information, that information should never leave the country. So let's start with Canada Central. If I wanted to, optionally, I can use what we call replication. Now, let's make sure we understand what Azure means by replication over here. Remember that, as I said, no matter which level of replication that you choose, the lowest level of redundancy that you have in Azure is 3 copies. All right, you cannot go lower than that, but I can go higher than that. In the case of Canada Central, the lowest level is what we call locally redundant storage, LRS, which means that at this point I've got 3 copies, right? Because I've selected Canada Central, that will be stored in at least one of the Azure building in Toronto, and 1 copy would be stored in ideally a second building, separate building in Toronto over here, just in case one of the building for whatever reason were to go down. So that's my locally redundant storage. I can also provide geo-redundant storage, where now I can ask Azure, don't make this information or don't store this information strictly in Toronto. I want you to replicate it to another data center. Now, which data center is it going to replicate it to? Well, the answer to that is it's paired. All right, in my case, it's going to be Canada East. How do I know that? Well, be aware that every data center in Azure is paired. They're always built in groups of 2. And the reason is, when it comes to replication, as we're looking at right now, replication always occurs between paired data center. There's a number of reasons why it's built this way. One is to ensure that we always have a fast pipeline between data centers, all right? In the sense that if I'm going to do a lot of I/O on my storage account over here in Toronto and I replicate it to Quebec City, which is Canada East, I want to make sure that there's little to no latency when it comes to that I/O. Microsoft has a dedicated pipe between those two data centers that is tremendously fast. Now, I haven't tested it myself, but I know some folks that I've worked with who tells me that they found that the latency from Quebec City to Toronto was 2 nanoseconds. Now, again, I haven't tested it myself, so I cannot attest to that, but I was told that from their test, and that's a third-party test over here, we're talking about 2 nanoseconds, not milliseconds, but nanoseconds latency over here, right? So very, very fast pipe over here between the data center. So if we were not using paired data center, then there's a chance that we might have to hop across multiple Microsoft data center, which will slow down replication. So that's one of the reasons why it's paired. Another important reason over here, indirectly, it's also for legal reasons. We want to make sure that if we do geo-redundant storage, with the data never escapes whatever country we're in, right? So in my case, it's always going to stay in Canada. If I were to select, for example, East US, well, East US, I know from experience, is paired with West US. So I know that if I'm working in the States, working for American clients, then the data will never escape the US soil, right? And it doesn't matter, there go Japan East, Japan West, Korea Central, Korea South. You can see over here, they're all in groups of 2. They're in groups of 2 for pretty much every region for that very reason that I've mentioned over here. So I'll leave it as Canada Central. Now, one caveat I'd like you to be aware of when it comes to replication, replication is disaster recovery. It is not continuity. It is not fault tolerance, right? So it is disaster recovery in the sense that if something dramatic were to happen to the Toronto data center, right? Meteorite strikes Toronto City, wipes out the data center. Tomorrow, we've lost everything. If I have geo-redundant storage, well, the data continues to exist in Quebec City. Unfortunately, the data is not accessible for my application. Right? I can't access it directly. Instead, when Microsoft brings back up the Toronto data center, when the Toronto data center comes back up, if the data is lost, then the data center will recopy the data over from Quebec City. So it's a disaster recovery, not continuity, not fault tolerance. There is a third option, read access geo-redundant storage. What does that imply? Well, what it means over here is that we are going to make the offline copy, the copy in Quebec City, read access, read only to the application. Now, the application would have to be written accordingly, in the sense that now there would be 2 URIs that it would use to access the data, one for Toronto, one for Quebec City. The one in Quebec City is read-only, all right? So I would not be able to modify the data. And the idea over here is if the Toronto data center goes down, my application is no longer able to access it. In my code, I might have written my application where if for whatever reason I cannot access the data in Toronto, as a backup, let's see if I can open up the data in Quebec City. But again, it would imply that I would have written the code accordingly. Or at a minimum, if I need to access the data while Toronto is down by providing read access geo-redundant storage using command line tool, using the Azure Portal, using the Azure Explorer, different tools, I would be able to connect to the Quebec City data center, view my data, but again, I would not be able to modify. So that's business continuity, not fault tolerance. Well, fault tolerance, yes. Oh, no, sorry, not fault tolerance, but disaster recovery and business continuity. So moving ahead when it comes to that, so I'll leave it as is when it comes to geo-redundant storage. Actually, I'll go to locally redundant storage in my case. So when it comes to premium storage over here, standard versus premium storage, do you want to use hard disk you want to use SSD. All right, that's a bit of an oversimplification over here, but be aware that premium storage has limitations as to what you can store on it. As I select premium over here, notice that I lose the ability to specify, where are they? My virtual network, but my access tier, and also the type of storage I can put in here. I don't see it right now. I'll show it to you later on. So I'm not going to use premium over here because I want to gain access to all the capability of storage account, but premium, again, bit of an oversimplification, but stored on SSD as opposed to spinning platters. Access tier, this is new-ish. Cool versus hot. Cool, you pay less per gigabyte that you store, but more per I/O operation. Hot, you pay more per gigabyte that you store, but less per I/O operation. So if it's a backup type of solution, if it's a historical record you want to keep, that sort of thing, something you're not going to come back to very often, cool storage. If this is something that is continuously maintained by the organization, probably you'll want to use hot storage. All right, that's a new-ish option over here. Secure transfer required. What this means over here is strictly from Azure to Azure using dedicated pipe. Should Microsoft encrypt the data on top of your whatever encryption you might have put in place? Yes or no. Some governance, some data governance might require that, right? So you can choose to enable or disable it over here. I'll choose my same subscription. I'll use my same resource group where I'm going to store my storage, so Contoso Insurance JF. I'm not going to get into virtual network. That's another discussion we could have, but yeah, now we're getting into infrastructure, not platform as a service. So I'll leave that aside for now. If necessary, at the end of the session, we can talk about IaaS in Azure. And I'm not going to get into data lake storage over here. Actually, I cannot enable it over here. So let's create the storage again. I've got my automation option, so I can see my ARM template. I'm not going to get into that just yet. Let's move ahead. So deployment in progress. My storage account is being created right now. I'm just going to take a look at my deployment. So my database is good. My web application seems to be stuck for whatever reason, right? I suspect that something went stale in my demonstration over here. I will recreate the web application over here because it seemed to have fell over here. I've seen that happen from time to time with the portal. If I can give you a strong suggestion though, I'm doing things right now with the portal. I'd like to encourage, however, the developers and the administrative team to familiarize themselves with the automation tool in Azure. In other words, the command line, right? You've got a built-in Cloud Shell over here that it can use to issue commands directly in Azure. You could, of course, use your PowerShell. If you're running on Windows, you could use your Bash Shell. If you're running on Linux, to do your Azure administration. And I strongly encourage anybody who wants to get serious about managing Azure, learn your command line. Familiarize yourself with your command line. It gives you a lot more capability than what your dashboard, your portal has to offer over here. And we'll talk a little bit about the command line time permitting, but I'll leave it as is for now. So my storage account has been created. We're good to go. So the next thing I'd like to do over here is I'd like to start transferring information over to the web. Let's have to the cloud over here. Let's have a little bit of fun with that. Let's begin with the database. To transfer the database, let me go into my database over here. Remember that the way that databases are structured in Azure is that you have a database server which can host one or more databases, similar to the way you probably do it on-premise already. You can create as many servers as you want, as many databases as you want, not a problem. It becomes a question of how do you want to administer your resources. Oh, and I'm seeing a question over here. With the web app not starting, are there logs available in Azure or will that be covered later? That's where the command line comes in a little bit friendlier because it does give you access to those logs if you want the result of those operations. Otherwise, I'll have to take a look at the actual deployment, find its correlation through Azure. it's a little bit more painful to do. There's my correlation ID. I'm not necessarily going to demonstrate that. If we get a chance, I'll be happy to do that. PaaS. Is this a demo considered IaaS or PaaS? Is this a Azure Virtual Machine or App Services? It will be PaaS. All right, you want to migrate to the cloud? I strongly recommend go the PaaS route. The IaaS route is essential in some circumstances, but I can speak from experience over here, having helped numerous companies work with the cloud, migrate to the cloud. The biggest mistake by far I see out there is companies, especially small organizations, but I've seen some small organizations, some large organizations as well, attempt to just copy and paste their data center in the cloud, their infrastructure in the cloud. It will work. It is possible, all right? But I will warn you right now, it will be difficult to maintain, and more importantly, you're not going to save anything. You're not going to save time. You're not going to save money. You're not going to increase the stability of your application. Quite the opposite. This is not cloud computing. So it is okay to use VMs in the cloud, but use them as a last resort, all right? Start with PaaS services. So going back to your question, is this a PaaS demo? It is entirely PaaS. I'm not saying that using IaaS is wrong, but if all you're using or the majority of what you're using is IaaS, I don't think we're doing cloud computing at this point. Are we going to take a break? Well, Diana, I'm sorry, I'm going to have to say no. The reason is we're limited to 2.5 hours over here. I want to try to wrap up my demonstration and not too long to handle any questions. So if some of you want to have a bit of break as we carry along, please feel free to do so, because I will be doing this nonstop. So my apologies for that. And it's a pricing model the same as IaaS, since it claims as a VM. Short answer is PaaS is much cheaper than IaaS. Cheaper, not just in terms of the cost of the resource. Let's say if I were to install IaaS on a VM and run that and do an equivalent web application with kind of sort of equivalent hardware, the web app would be cheaper than the IaaS. All right, and it would be cheaper not just in terms of what Microsoft would charge you at the end of the day, but it would also be cheaper in the administrative work, because now you don't need to manage the operating system, you don't need to manage firewalls, you don't need to manage antivirus, you don't need to manage routing, you don't need to manage loggers, you don't need to manage intrusion detection, intrusion, what's the word? Mitigation. So all of those are provided to you out of the box in Azure when you use PaaS. If you use IaaS, it is your responsibility to set up the OS. It is your responsibility to configure those additional resources. And if you want to use third-party tools to do your login, to do your monitoring, to do your even Windows tools to do all that, your security, again, your intrusion detection, your malware detection, your antivirus, that sort of thing, then these are additional licenses you'll need for that. So going back to your question, it's a great question, but the important part over here is PaaS, and I'm speaking not just from theory, not just from academic over here, but having gone through that numerous times in my career. PaaS will be much cheaper than IaaS long-term, right? Short and long-term. It will be cheaper not just in terms of what you pay Azure or AWS or GCP, but cheaper in terms of the administrative effort you guys will do back at work. So go with the PaaS route. If all things are equal, you have a choice between going the IaaS and the PaaS route, go the PaaS route. So that said, let's move ahead. I'm going to come back to my website, see why it's being a bit recalcitrant right now. Instead, let's talk database. So here's my SQL database. So what I'd like to do over here is fundamentally transfer my existing database over here, my Contoso insurance database, to the cloud. How are we going to do that? Well, let's explore a couple of things. The first thing, actually, I'd like to show you over here is this is SQL Server running as a service. All right. If you're not familiar with Microsoft SQL Server, don't sweat it too much, but I do want to emphasize that it is SQL Server running as a service. The database itself has a server name. All right, so we've got a database name and a server name. The database name is Autoscale Insurance. The server name is a DNS name that I can see over here. I'll actually copy it. There's a click to copy button over here. Let me go to my SSMS SQL Server Management Studio. And what I'll do over here is I'll connect to another database engine. This time it won't be my local server. It'll be my machine, my database running in Azure. I can't use Windows authentication. I'll have to use SQL Server authentication, but I think you remember that I did provide a top secret username and password over here. Let me try that over here. Connect. And then, boom. New firewall group. Your client IP address does not have access to the server. What's happening over here is that for security reasons, Azure does not permit any connection, any direct connection from the internet to my database server running in Azure. And I think you can understand the why of things over here. It would be a serious security concern if anybody and their dog could just try to blast any login to my database server running in Azure. So by default, that database server is fully firewalled. No way to touch it, all right? In many cases, that would be the desirable way to go. I'm going to keep it fully firewalled. But there are circumstances where I may want to make that database server accessible, maybe from my data center. All right, I want my data center to be able to connect to that Azure SQL database transparently, where now that SQL database running in Azure could participate with activities in my data center. In my case, I'd like to be able to transfer information that I have locally on my machine to my Azure database. And the easiest way by far would be to connect to that database locally. So what I'll do is I'll head back to my Azure over here, go to the server itself. There should be a link to the server over here. Where are you? There you go. Actually, there's the set server firewall, so that'll bring me to the server immediately. So here is my Autoscale Insurance JF server, SQL server. And what I'll do over here is I'll add an exception to the firewall over here. I'll add my client IP. So this will permit the IP that I'm using right now to connect to Azure to talk to the server. So I'll click on Add Client IP. It adds it. I'm just going to rename it. I don't like the default name, so I'll call it, let's say, JF Dev Machine. There we go. All right. So here's the IP address. Later on, I may want to disable that. But something that we usually do de facto is allow access to Azure services. So whatever applications are running in Azure, let's say my web application, my web API application, maybe some VMs that are running in Azure, those would have access to the database, assuming they have, of course, the proper credential, the proper connection string, they would be able to talk to the database. So this firewall only limits, only blocks internet access to that database. Anything that is running within Azure would be able to talk to that database, again, assuming that they have the proper credential and they're in the proper subscription. And there's other ways by which you can secure it. If we get a chance, I'd like to discuss that. But let me add, that's the only change I'm going to do over here in Azure. There you go, a successfully updated firewall route. Let's try that again. I'm just going to cancel out of here, try to reconnect to my server, and boom, I'm in. All right, it was as easy as that when it comes to connecting to my database. And I do want to emphasize that here I am using SSMS running locally on my machine, but I am connected to a SQL Server instance in Azure. So pretty much anything I can do with SQL Server on-prem, I can do with Azure. Not everything. I cannot manage the servers themselves. It is running in virtual machine. It is actually running in a cluster, for those of you who are wondering, but I don't manage that. It's managed for me by Microsoft. So there's actually 2 VMs that I'm using right now for the price less than the price of 1 VM over here. So right now, if I take a look at this, I can see there's my Autoscale Insurance database. So that's the database that I've created over here. Contoso Insurance. Inside the database right now, there is nothing. I take a look at my tables. As quickly as it can come up. No, there's no tables in here, right? So what I'll do over here is I'll go to my local Contoso Insurance database over here, right-click, task, and let's deploy, there you go, deploy database to Microsoft Azure SQL Database. So it's built in over here. But the cool part I like to emphasize over here is some of you might look at this and say, hey, okay, that's cool, I can push to Azure, but what if I change my mind? I want to bring it back locally. Not a problem. I can do that as well. It's SQL Server to SQL Server. It doesn't have to be SSMS. I could use other database management tool. As long as they speak SQL Server or Sybase, I will be able to connect to Azure. It's just using the standard SQL Server protocol over here. So nothing changes at this point. So let me do the deploy over here. I'll just fast forward through that. So server connection. See if I can pull up my connection that I've established previously. New database name, actually, don't want to create a new one. Can I specify? I'll see if I can override it. New database name, Contoso Insurance. And then finally, what size do you want to use? We've talked about the basic size, maximum database size. And then temporary file name, we're going to use fundamentally a backpack to transfer that over. So again, for those of you who are familiar with SQL Server, if you've done similar operation where you're exchanging information from database server to database server in the past, that should be familiar to you. Let's move ahead. We're so afraid of that, so let's just call it JF. And so that's going to create a new database in Azure. In other words, I did not even have to create the database in Azure before the fact. Shouldn't take too long, but while that's spinning, all right, there we go, finish. There you go, doing the export right now. And again, for those of you who've done that previously in SSMS, the output will be familiar to you. While that's happening, I'll just go back to my SQL database over here. Actually, I'll do a full refresh of my UI. Give it a second or two to fully initialize. And I'll go into my SQL database. It may or may not show immediately. No, still in the process of being created. Let's go back to the deployment. There you go, spinning, going pretty fast over here. It's just about to deploy it over here, and eventually that new database will be available to me. Now, what I've done over here is really a lateral motion, moving my database from on-premise to the cloud. It was a very trivial endeavor over here. Trivial in the fact that, first of all, I am using the same database server, SQL Server. If you're using MySQL or MariaDB, not a problem. This is also supported as a first-class citizen in Azure. If you're using Oracle or DBMS, if you're using Sybase, you're using DB2, you're using Postgres. Actually, Postgres is also a first-class citizen now in Azure, but any other database are typically supported, but by the vendor, not directly by Microsoft, but by vendors. So if I wanted an Oracle or DBMS in Azure, not a problem, I could do that, but I would be going through an Oracle template as I create a resource, not a Microsoft template. In other words, as I go to create a resource, Oracle RDBMS, and there we go, I've got servers that I can use over here. Well, I'm not seeing the one from Oracle directly, but there's, actually that's MySQL. That's kind of a cheat over here. Not seeing Oracle, unless they're pull up. I know that Oracle is trying to start their own cloud service, and I'm getting the sense they actually pulled out of Azure for whatever reason. They're a loss in my opinion, but there's my SQL on Ubuntu, but MySQL is a first-class citizen as well in Azure. There you go. Actually, there's even a template over here by Microsoft to create a web application running on Linux with a MySQL database server in the backend. Just a little FYI for you guys. And as I mentioned previously as well, another newcomer to the ecosystem is Postgres, another very popular database, open source database out there. First class support for that one as well. So just a little FYI, while that's still spinning, so importing package schema into database, updating database. Let's just see where we're at. I'll go back to my SQL database, see if it's now visible. Do a refresh. Not yet, but it will become visible very soon. All right. So while this process is completing, seeing a couple of questions over here. Can we migrate our on-premise database to Oracle or NoSQL database? To NoSQL, not directly, nor would I recommend you deploy directly, since NoSQL doesn't use a relational model. You have to somewhat rethink how you want to organize your information. It is a different structure. It's a much more flexible structure, and it does provide very interesting performance advantages over traditional relational databases. But I would recommend you first consider how we'd like to organize the information, maybe write a script to transfer your relational data to your NoSQL schema list structure. So when it comes to that, I would recommend you do that. Why would you call apps first-class citizens? I joined a few. Okay, sorry. What I mean by a first-class citizen, I mean directly supported by Microsoft. We don't go through a third-party vendor to support the resource. So things like MySQL, this one is created and supported for you by Microsoft. I don't have to go through Oracle, which is actually the steward of the MySQL source code for that. So I'm hoping that this helps answer your question. And when it comes to migrating your database, migrating from, well, here's a scenario that I've seen very often, from Oracle to Azure database, that I've seen done very often, from, let's say, a non-Oracle database to Oracle in Azure. Generally, I haven't seen that. And the prime reason is Oracle is not cheap to run. Chances are you'll want to either stick to the solution you're already using right now, avoid also vendor incompatibilities, doesn't matter what you use. And also to save on costs, you'll probably want to go through either the same vendor that you're using. You might be able to carry over some of your licenses to Azure. And the second thing as well to consider is vendor incompatibility. Unfortunately, every database is different. So moving ahead, let's see how we're doing when it comes to my database. There you go. It is done. Close. Wish I could see it over here. That would make it a little bit more interesting. Let's go to the server directly. That's the server to which I pushed my database. And let's take a look at the databases on the server. There we go. Here's my Contoso Insurance JF. And it's still not live. So it may have been deleted. No, I've seen that before. What the portal is telling me is that, oh, I know the resource exists, but I can't find it, probably because it's still being built in the back end over here. So the transfer has completed, but there might still be some indexing or some allocation required at this point. So eventually it will come up. Also the reason why I'm not seeing it directly in the portal just yet. So I'll leave that as is and move to another part I'd like to demonstrate. I know we're running a little bit not necessarily short on time, but there's about 45 minutes left for the presentation. I do want to reserve some time at the end, so let me move to another tool. Actually, personally, my favorite tool when it comes to doing Azure administration. Well, one of the two favorite tools, PowerShell. I'm saying one of my two favorite tools, PowerShell or what was formerly known as the XPlat CLI, the cross-platform command line interface, the AZ command, which was originally written for Unix, but runs equally well in the Windows world. Both the PowerShell and the XPlat CLI for Azure provide full administrative control and expose pretty much every capabilities that's open for you when it comes to working with Azure. So again, if you want to unlock the capabilities in Azure, you want to get serious about working with Azure, the same applies for AWS or GCP, familiarize yourself with the command line interface. That's where you're going to get most of the capabilities over here. I'm just going to change the font size so it's a little bit bigger, hoping that will be easier for everybody to read. So let me switch over here to my cross-platform tool over here to explore a couple of administrative tasks that I could perform in Azure. The first thing I'll need to do over here is connect to Azure. I'll need to log into Azure. To do that, let's use add Azure account. Now, for those of you who know your PowerShell, you'll recognize that this is a PowerShell commandlet. If you know your PowerShell reasonably well, you'll feel right at home over here. If you come from a Unix background, or maybe even more of a traditional command line background, you may prefer the AZ command instead. All right, they'll give you equivalent capability. One will give you the capabilities using a PowerShell-ish approach. The other one using a Bash-ish approach. So moving ahead when it comes to that, let me log into Azure. Now, Azure uses pretty much OAuth 2 for authentication. If you know OAuth 2, you know that this is an authentication mechanism that requires user interaction, which means that no matter which tool that you use to connect to Azure, chances are it will have to pop up a login form in a separate browser window. So let me just log in as myself quickly before it grants access to the application. Now, I've already authenticated before, so it remembered me. That's the reason why it didn't ask me for my password. Just wanted to confirm the user account. There we go. I'm logged in. And now that I'm logged in, I can perform some work in Azure. For example, I can do a get Azure Database or SQL Database. Just as an example over here. Oh, should have been get Azure RM. My apologies. I just realized I used the wrong login command. Azure RM account. There's two flavors, two Azure command lines, commandlets over here. You've got the Azure and Azure RM command line set of commands. The difference between the two is Azure RM uses the resource manager. We hinted at this one previously. The Azure does not use the Azure RM, uses classic resource model. So most administration that you are going to do, for example, get Azure RM SQL Database, will require me to add, to prefix the command with Azure RM, Azure Resource Manager. So actually, let's do database server. There's an SQL server. Resource group name. How did I call it? I think it was JF. Actually, there we go. I don't remember what my resource group name. I could look it up on a portal. Let me do a get Azure RM resource group. There we go. Here's a list of all my resource group. I was looking for the resource group name Contoso Insurance JF. Let me query my server over here. I'll say use the resource group name Contoso Insurance JF. And there it goes. So that brings up my SQL server over here. From here, I could do things like bring down my SQL server, add databases, that sort of thing. Or I could, let me go back to one of my previous commands, give me the database running in the resource group Contoso Insurance JF on the server name. Boom, server name over here. And there go. Here are the three database, or there should be two. Yes, two databases that we have over here. The database name Contoso Insurance, and the other one Contoso Insurance JF. So here I'm doing some administration using the command line. I can remove Azure SQL Database. Actually, I'll just bring back the previous command. It'll be easier. Remove Azure SQL Database. I'm going to make sure it's the right command. I'll use tab completion to confirm that. Boom. And I'll specify database name. I want to remove Contoso Insurance. So the extra one that I created earlier. And it's gone. All right. Now, a couple of things I want to highlight with my very quick demonstration that I've done over here using the command line. Now, I know that not everybody might be fond of the idea of using the command line. If you're really against it, that's okay. You've got the UI, you've got the Azure Portal over here, point and click, very easy to use, very convenient to use. But when it comes to the command line, I'm hoping that you've seen that I was able to access my information pretty quickly. As quick, and I like to think in some cases faster than if I was trying to do this with the mouse, trying to do the same thing with the portal. Another thing as well is when it comes to that command line, I'm using PowerShell over here. It's very convenient to use. It takes full advantage of PowerShell. So by tab completion, using standard command line, using the pipeline, if you're familiar with your pipeline in PowerShell, so it gives you access to all of those great capabilities when it comes to managing your your Azure infrastructure. Now, one of the reasons why I wanted to get into PowerShell, I did not actually have to use PowerShell over here, but I want to go to my cloud native project over here, Contoso project. I think it's under files. There you go. I've got a series of PDF documents. I want to push those to the cloud. All right. I want to make those available in the cloud over here. Right now, they're on my C drive. How do I transfer that to the cloud? I did earlier create, and I'll switch back to the portal for that one, make it a little bit more visual, create a storage account. I'll go to my resource group, head into Contoso Insurance, and storage account. I'll wait for them to load. And there's my storage account. I can see the type over here, storage account, Contoso Insurance JF. So what is a storage account? Conceptually, we understand that, yes, this is where we store information, but how's that information structured? Where is it stored? That sort of thing. Well, the where again, we've chosen a location, but a storage account has 4 distinct type of containers we can use. This is where the data actually exists. So my Contoso Insurance JF over here doesn't actually store anything. I cannot actually push anything to that storage account over here. Instead, what I need to do over here is create either a blob, 1 or more, 0 or more blob services, 0 or more file services, tables, or queues, depending on the needs of my application. Blob allows you to store, well, as the name implies, a binary large object. It could be a file, could be large or big, doesn't really matter. You can see this as a bit of a file storage. It is not a file system. So this is not a C drive or D drive. It doesn't have the concept of directories. This is strictly to store files. Those files could be accessed directly by the internet or could be protected and only available to the application. You control who has read access, who has read-write access to those, and I'll demonstrate some of that very soon. File is basically a SMB share. All right, if you, an example where this might be used is if I have an existing on-premise application, let's say a legacy application, that application wants to write to a C drive, a D drive, an E drive, read-write information to a regular file system. It requires that. If I move it to web application, well, web application have a shared drive that might be shared across all instances, whether the instance is dedicated or not. The file system is shared and for the most part read-only, which means that a legacy application written in no matter whichever programming language that needs read-write access to a file system would fail. What about also if that file system needs to be written to by different application? Well, that's where I could create a file share, uses the Microsoft SMB3 protocol over here, also supports SMB 2.1 if necessary. So the idea over here is I can create a file share, so I don't need to bring up a new VM, create a big massive disk on that VM, share that disk as a network share, then connect it to my web application. I don't need to do any of that. All I need to do is create a file share in a storage account. Much cheaper, much less maintenance as well. Table storage is your poor man's version of a NoSQL database. I don't want to make it sound like it's not good. It is actually very, very good. But I'm calling it a poor man because it's about the least rich version of a NoSQL database you have available for you in Azure. You want to go the NoSQL route? Take a look at CosmoDB. CosmoDB is 100% compatible with the table storage, but supports a lot more. Queues, well, you want to get serious about not just cloud development, not just native applications in the cloud, but you want to create resilient application, fast application, start taking advantage of queues. I suspect a lot of you probably use queues on-premise, maybe using MSMQ or IBM MQ or similar products, maybe queues in your JE application server. It doesn't matter what it is. Azure has actually a number of different queues that we can use depending on the need of the application. Here's one of them, storage queues, which integrates very naturally with RESTful type of philosophy when it comes to developing application. So those are the 4 different types of storage that are available for us, storage types that I can create under a storage account. So if I want to store anything in Azure, I could use, of course, a relational database. I've demonstrated that for the most part already. I could use other type of storage. I could use a virtual machine with a disk to store information on that VM. Not the most efficient way, but it would work. In some cases, to support legacy application, might be a necessity. I could use Hadoop, HDFS, Data Lake Store, to store information. But in my case, because I want to store a series of PDF files in Azure, make them scannable, make them searchable, maybe distribute them on the web, a blob storage would be the natural way to work. Why is that? Well, let me demonstrate. Let me create a blob storage right now. So I'll go into my storage. There's no blob storage container. So I'll create a new one. It's just a name. Call it whatever you want. I'll call it policies. That's a name that I've chosen. Could have been called whatever you want. It has to be unique to that storage account. All right. So it doesn't have to be unique to Azure, just to that storage account. Public access level. Do I want to allow folks on the internet to be able to view those files that I'm going to put in that storage container? The default is private, no anonymous access. So nobody has access to that storage account, period. All right. How do you access it? We'll come back to that. I can, if I want to, provide read access, anonymous read access. This is especially useful for CDN type of scenario, content delivery network type of scenario, the scenario where I want to make some large files, let's say some multimedia file, video, audio, or maybe some large PDF, large XML files, log, but I want to make them publicly available, where anybody who knows the URI or the URL, if you prefer, to that resource can access it. Could be useful for JavaScript type of application. But this is, at this point, anonymous read access. They can read it. They can't modify it. But of course, it does imply they need to know the name of the blob. They need to know the full URI of the blob. If they don't know it, they don't have access to it. So in my case, I'll leave it as private. These are insurance quotes or insurance information. I don't want to make them accessible on the web accidentally. So by making it private, nobody will have access to those. Well, nobody has access to those. That's going to be problematic. I want to be able to transfer those files to Azure. So my PowerShell over here needs to be able to not just access that blob storage, but write to it. So how do we provide access to our application to be able to maybe read or write or control what they can do with that blob storage, right? Well, the way we do this at the container level. So I'll go back to my blob storage container. Where's my scroll bar? No. Go back to the resource group. Backtrack a little bit too much. And back to my storage account. All right, if I can emphasize at this point, in Azure, anything that you store will be stored in a storage account. A storage account is composed of containers. There are 4 types of containers. They're all named. You choose the name. You can create as much of those as you want. There is no cost to create a storage account. There is no cost to create containers. The cost is going to be per gigabyte that you store. If I remember correctly, it's about 2 cents or 0.2 cents per gigabyte that you store. So very cheap, plus IOs. So let's move ahead when it comes. Oh, actually, I don't want to go to the blob themselves. Let's go back to the overview. So what I'd like to be able to do over here is provide access to application to read or write that blob storage. How do we do that in Azure? Well, everything happens through RESTful endpoint. And the way that we do it, there's 2 ways by which we can do it that I'd like to highlight for you. The first one would be using what we call a shared access signature, which will make use of access key. Actually, I'll begin with access keys, and I'll come back to SaaS signature later on. The second way would be managed identity. Managed identity is a little bit more new in Azure, but can be much more secure as well, depending on the architecture of your application. So what is an access key? Well, an access key is an all or nothing type of key. We can see over here that Azure gives you 2 access keys, and that's for the storage account as a whole, not per container, but the entire storage account. So every container in that storage account shares the same set of access keys. There's 2 of them. Why 2? There's no difference between them. Whether I use the first key or the second key, it will not change my capabilities in Azure. The idea over here is if you give access to one of your applications to an Azure storage container using either key 1 or key 2, and you decide that you want to revoke access to that application. Well, first of all, giving the entire key to an application is highly permissive. At this point, the application has complete control over the storage account. They can do whatever they want. So if the application is well written, not a problem. But if that key gets compromised, gets loose out there in the wild, well, at this point, they have complete control on your blob container. They can view any blob. They can view all your table, your files, your queues. They can modify them. They can create new ones, so they have complete control over everything at this point. So that key should be strongly kept. If a key gets compromised, I can regenerate it. There's my regenerate button. Notice right now my key begins with JVCT over here. Regenerate. This will create a brand new key, strongly generated using a strong random number generator. And at this point, any application that we're using the previous key will no longer be able to access the blob. So I've locked out any applications that use that old key. So to prevent scenarios where I need to regenerate a key, but I don't want to break all the existing application that accesses the container, what I can do is go to those applications, give them maybe the second key, which hopefully has not been compromised. So give them the second key. Now they're going to use the second key, regenerate the new one. Now any application that used the old key, or let's say crackers that might have gotten their dirty little finger on the old key, no longer have access to that information. We're good to go. So that's the reason why we have 2 keys over here. However, again, keys are all or nothing. They're highly permissible. That's not my favorite way of giving access to an application to a blob container. So typically what I'll create instead is what we call a shared access signature, a SaaS token, where now I can create a SaaS token using the exact permission that I choose. So notice, first of all, which services do I want to give access to the application? Do I want to give them access to my blob, my files, my queue? I can be selective. What type of service? Can they access the service itself? So create, delete blob. Can they query a container? What blobs do you have? or the object itself, read, write, modify blobs. And when it comes to the permissions themselves, now I can choose. Can they read? Can they write? Can they delete? Can they list, enumerate the blobs? I'm not going to go through the whole list. So I can choose. I can be selective. I can also choose from when to when is that shared access signature token available, right? I can time it out. So for example, for an application that's meant to run for a long time, I might elect to keep it around for a whole year. Now, it does preclude, of course, that next year before August, what are we today? August the 14th, before we hit August the 14th, I will have to generate a new SaaS token for them to avoid expiry, or big hint, I'm not going to get into that demonstration, use policies instead, so you don't have to update the application at all. But at this point, I can choose from when to when is that key available to them. Time zone, which time zone you want to use. Allowed IP addresses, which IP or address or IP addresses have access to that blob. So this could be useful if I want to grant access to a blob to a very specific machine, or let's say just a machine in my server room. I could whitelist just the machines in my server room. Allowed protocol, are we going to use HTTPS only, or are we going to allow insecure HTTP? So again, you choose whatever you want over here. And finally, which key do you want to associate with the signature? The application never receives the key, but if I reset key 1 or key 2, depending on which one I choose, I also block access to that SaaS signature. But the important part over here is, let me click on generate SaaS and connection string. Now, I would not do that manually. This would be an automated process, but I'm demonstrating things manually. What it does over here is it gives me connection strings that I would then provide to my application, whether it's a Java application, a .NET, a Python, a Go, doesn't matter what type of application, the connection string is the same. You use the SDKs that I've introduced you to on GitHub previously. So download your SDK or use your package manager for your stack to install the SDK, and then provide that connection string to the SDK, and it'll be able to access that connection string. Now, the whole reason why I'm discussing this right now is to start winding things down. I want to transfer those files from my local machine to Azure. How am I going to do that? I could, of course, write a little application using Python, using Java, using .NET, doesn't really matter, and have the application read those files, use the connection string that I hinted at previously, that I've shown you over here, to push the information to Azure. But I'm not going to do that. I'd like to introduce you to another useful command line utility provided by Microsoft, AZ Copy. AZ Copy is a command line tool written specifically to copy to and from blob storage in Azure. So very convenient way to populate information in your Azure cloud, or download, if you want to, information from Azure. So what I'm going to do over here is I'm going to use AZ Copy to copy all the files in my current directory to, you can see the command line parameters are all over here, to the destination. The destination, actually, I'll need to provide the endpoint, so not a problem. What I'll do is, actually, I'll do it a little bit manually. Let me go to my blobs. So I want to transfer it to, that's cute. We'll refresh and solve that. There we go, to the policies blob container that I created earlier. All right, no blob found over here. I'll go to my properties. Here's the URL that my application needs to use to connect to that policy. I've shown you the connection string, which also includes the URL. So if I was writing the same thing again in Java and Go and .NET, whatever, I would not have to specify the URL, just the connection string. But I'll do things a little bit more manually to highlight how things happen behind the scenes. I'll specify here's the destination. So I want you to grab every file in my current directory, send it to my blob container called contoso-insurance.js.blob.windows.core.windows.net/policies, policies being the container over here. Now, if I just press enter, it's going to fail. It's going to fail. It is incorrect. Oh, because I need to specify the source. Say current directory. And there you go, the syntax. Okay. I was hoping to show you an access denied, but the command is smart enough to realize that, hey, JF, it's not going to work. It's not going to send it over because, yes, I have a URI over here, but you need to specify either a destination key or a destination shared access signature that I've discussed earlier. So one or the other. In this example, I haven't created a stash. Well, actually, I did, but I did not save it. What I'll do over here is I'll specify, give me the, here's the destination key. What is the key? Well, I'll need to go back to my blob access key. Again, it doesn't matter which one I use, one or two. They don't. There's no difference between that. The reason why we have to is so we can cycle the keys for application. Let me copy key one again. Doesn't matter which one I choose. Let's paste it over here, and let's give that a quick go. And there we go. So now we're transferring everything. Now, I did not specify /s. There is a little warning over here, a suggestion to transfer directory. Please specify recursive mode so that it goes down directory, subdirectory, subdirectory. But in my case, it's a flat hierarchy. There you go. I've transferred 91 files over here. It wasn't a very big transfer, 12 meg, so it took no time. But let's go back to the blob itself. Here's my blob service. The blob was called policy. I could have had more than one. And there you go. Here's all my PDF files uploaded to Azure using AZ copy. So again, I know that the command line is not necessarily everybody's favorite way to work when it comes to Azure. I could have done the equivalent without doing using command line. I could have used the upload button as well, but I wanted to introduce you to AZ copy, useful command provided by Microsoft, not installed by default, but just Google it. You'll find it pretty quickly. AZ, oh yeah, copy. And there you go. There it is for you. I download the latest version to copy a file. There's a version for Windows. There's also a version for Linux. Not seeing mentioned over here. There you go. AZ copy on Linux. All right. Works the same in both versions. All right. So moving ahead. Sorry, I've missed a couple of questions over here. Let me catch up a little bit and also start to wind things down. All right, so for a reason of some company needs to keep data on-prem, is the application connected from Azure to on-prem data can work as well? Absolutely. Is it better to use API to access on-prem data? It depends. That's a really good question over here, and I'd like to discuss ways by which we could do that. If an application in Azure needs to access stuff on-prem, the ideal approach would be to use what we call ExpressRoute. ExpressRoute basically implies that Microsoft basically built a dedicated pipe between your data center and Azure, say Canada Central, Canada East, or whatever data center you want to use, so that at this point, basically, we're sharing the same network. The application in Azure cannot talk to servers that are running in your server room. Servers in your server room can now send packets directly through Azure. You're not going through the internet. You're going through Microsoft dedicated route at this point. So that would be the ideal way of doing it because A, you're working through a dedicated route. It is highly secure. It is very fast, high performance. The bottleneck really is going to be your gateway going out to your BGP, your border gateway protocol switches. So that would be, again, the ideal way of doing it. There is a cost behind using ExpressRoute, but I know of a lot of organizations, public and private, that use that. If this is not an option, another option available to you is VPNing. You can, in Azure, create virtual networks right? VNets. Was hoping they were going to be in here. I don't see them immediately. There we go, virtual network. So you could create a VNet, connect your application to that VNet, and configure a VPN, maybe a two-way VPN from that VNet to your data center. And at this point, we can exchange packets between the Azure cloud and your application. So at this point, we are going through the internet, but using a tunnel. All right, so all the information is encrypted, and from the purpose of the application running in Azure and your data center, we're still running on a private network. We're not hitting the internet. So that's another option that might be of interest for you. Third option, if you choose for whatever reason, not ExpressRoute, no VPN, virtual private network, then at this point, I would recommend maybe an API type of scenario where the application provides a mechanism to authenticate with an API, a publicly exposed API on the internet. So from Azure to your API to exchange data, ideally via HTTPS, right? That's where I would certainly go the API route. Should you go the API route, if you're using ExpressRoute, should you be using VPN? I'll say at this point, it's entirely up to you. Right? So it's a good question over here. If you need to keep your data on-prem, I know a lot of people who need to do that. ExpressRoute would be the preferred way to do it, and then your application could talk to your data center directly, connect your database or whatever data stores that you want. Otherwise, VPN. Otherwise, as a last resort, maybe API. But now you're adding a layer of complexity that ideally should not be there. Hoping that answers your question. Another question. At which point did you copy the metadata, and at which point did you actually copy the data from on-prem to the cloud? I would not say I copied any metadata. All the resources that I've prepared over here, my web application, my SQL database, my blob storage, amongst other I could have done, I've created manually using the command line over here, using the portal. I could have created them using the command line. As an example, I could have created a new Azure RM website resource group, and then specified the resource group, the name, so I could have created them manually. When you first create a resource, you'll either use your portal, you use the command line, whatever it is that you want to use to create, actually not website, but web app, to create whatever element you want to create over here. But after the resource is created, use ARM template. And if I can demonstrate that over here, to fully answer your question, I never really copied metadata for my environment. What I did is I rebuilt the environment in the cloud. And I would strongly recommend you start with that philosophy. Don't copy and paste your on-prem to the cloud. Instead, evaluate the business needs of your application and determine what services and resources best meet the business need of your application in Azure. Azure will offer a heck of a lot of capabilities than what we have on-prem, all right? Unless you have literally millions of machines installed with, I don't know how many tens of thousands of different pieces of software as you have with Azure, not including all of its distributed capability, chances are you only have a fraction of what the cloud has to offer. So evaluate, then create the environment. After the environment is created, all right, most of my environment that I've created in this session, let me go to my resource groups. Most of the environment that I've created, I've put, well, pretty much all of it, I've put in this resource group. The resource group, as I've defined earlier in the session, is an administrative and lifecycle boundary. Now that this is created, let's say I've done that in a dev-ish type of environment. I want to move that into a staging environment. I want to move that into a prod type of environment. The next thing that I would do is head to my automation script for that resource group. And boom, here is my ARM template to rebuild the exact same infrastructure in any other data center under any other subscription over here. Here are the parameters that I can change and adapt over here for those environments. And I will need to adapt those because some parameters will not be provided. Things like password. All right, I provided a password for my database server. That was never stored. So I will need to provide that password either in the parameters or when I apply the template as I execute the template itself. But now that my quote-unquote metadata is created, my infrastructure is created as code, I can now push it. If I need to update the infrastructure, let's say my dev team over here is adding new resources, tweaking some existing resource in the dev environment, we need to push that in staging, make sure that everything is good. All I need to do is re-push the ARM template, and I can do that automatically. Push the ARM template over here, tell the Azure just update the environment based on the changes, update Azure receives the environment, the ARM template updates the environment accordingly, so we don't need to bring anything down, we don't need to delete anything, it just updates the environment for me. Same thing as we need to move it to prod, I can push the environment to prod as code, so infrastructure as code over here, and we're good to go. So it provides a very smooth mechanism by which my dev team can define the environment and then transfer that environment in a fashion that requires no human intervention beyond potentially providing missing parameters, things like passwords, all right, to the environment. And if you want to skip over that, take a look at the Azure Key Vault. It's there to allow you to deploy sensitive information without the deployer having access to that. Really cool stuff when it comes to the Azure Key Vault. So I could store things like password, I could store certificate, I could store connection string that would be required in deployment, give access to one of my administrators over here to deploy a template, and the template over here would pick that information, say passwords and certificates and whatever it needs from the Azure Key Vault, never exposing that to a human being. So fully secure deployment, much more secure than having a dedicated team having to manage things like certificates and passwords that could easily leak out. So the last thing that I've done over here is when it comes to the data. So after I've got my infrastructure in place, well, then I've pushed my files to Azure. I've pushed my database to Azure. The one thing I did not get around to, and I can do that later on if you'd like, but we're starting to run low on time, is from within Visual Studio, I could have gone to my web application over here, and I'll start the process. Right-click. Visual Studio fell asleep. Right-click, publish. And again, I don't need to do that in Visual Studio. I could do the same in Eclipse. I could do the same in IntelliJ and my PyCharm, whatever IDE I might be using over here. And I can say, there, go push that to a Microsoft Azure app service over here. Mine seems to have failed, so I can create a new one. I'll do a publish right now and transfer my web application to Azure. Publish the web application to Azure. I'll create a quick one over here. App name, just get rid of the number over here. Web subscription. So I think my Visual Studio fell asleep. Resource group. Let's put that in the Conto, so insurance JF. App service plan. Okay, that one was created, so I'll use that one over here. And let's hit create. So this will create the app service. The next time I publish it, of course, I will not recreate the app service, but this will create the app service, aka the website, push it to Azure, it will be good to go. So this will both create the infrastructure and the push the code to that. Because I've pushed the infrastructure to, oh darn it, I've selected the wrong resource group. Poop. My apologies. It wasn't intentional over here, but I wanted to show you that now that I've pushed the application to Azure, that the resource group template would have also been updated to include the website. So going back to that question, I'm sorry if I went into a little bit more detail than I planned to over here, but I did not, quote unquote, copy the metadata. What I did is I rebuilt the infrastructure over here in Azure, and I think that's important over here. I don't recommend you carbon copy and paste your infrastructure to Azure or to AWS or GCP. Instead, build it and then transfer your data. And I've shown you different ways by which I could transfer the data manually through the portal, using the command line, using tools like AZCopy, using tools that you're already familiar with like SSMS over here. And then I get a question over here, is OAuth and JWT the same thing? I'm not sure what JWT is, but I'm going to say probably not. I'm not sure what JWT refers to. And I'm also, just to be clear, referring to OAuth 2. Azure does support OAuth 1, but Microsoft advises against using it. It's not as secure as OAuth 2. Azure also supports, what else? It supports a number of additional authentication mechanisms. I'm trying to remember the list, but OAuth 2 is generally the preferred one in Azure. So I'm hoping that this helps answer your questions. Any other question in terms of what I've demonstrated or what I haven't demonstrated over here in Azure? Oh, so I'm seeing there's a couple of more questions. Can I do English? Well, I like to think that I can actually speak the language, but I'm not sure what you mean by can I do English. And then I see a comment, yeah, command line is always faster. And again, I don't want to get into discussion of GUI versus command line. Personally, I do favor command line. I'm not going to shy away from that. I do also have a very strong Unix background, Linux background, but it's not the reason why I favor the command line. I favor code over documents, over UI. I find that it's much easier to maintain. I can throw it in my repository. That's actually a discussion that we had previously. Put in your Git repo, in your TFS repo. You can version it, so all those great advantages. Can you show throughout the Azure portal that the Contoso Insurance DB is gone? PowerShell status says online. The server should be online, but the database should be gone. Let's take a look. So I'll go to my SQL database. And it's no longer there. So I'm hoping that this satisfies your curiosity. Thank you. It was shown. Okay, so, well, there it is. It is gone now. And you saw me as I was going through that. I did not delete it using another approach. Oh, good question. Why not just use a secure FTP? For blob storage by design, but this is something that is heavily requested with Microsoft. Microsoft initially choose not to support FTP or SFTP or FTPS or any variant with blob storage. The only way to access blob storage for now is HTTPS and HTTP for reading. However, I can tell you that there's a huge demand out there for Azure to support blob storage via SFTP, so it may come in the future. So keep an eye out because I can speak again from experience, the demand is there. Is AZ Active Directory where the administrator's account managed? Is there a cost difference? Okay, so when it comes to that, Azure AD is free. There's no cost behind it. You can create as many users as you want with it. You can create as many directories as you want. You're not going to pay a penny over here. You can use your Azure AD to store administrators and define roles, who can administer what. And you can also use your Azure AD to store users of your application. You can also integrate it. There's different ways by which we can do that. Integrate Azure AD with your on-prem AD, or you can do federated authentication if you prefer. So all those scenarios are valid. But going back to the root of the question over here, is Azure Active Directory where administrators' accounts are managed? Yes. For example, if I go into my own directory, I've got a couple, but that's my prime one. I've only got one user, myself, and I'm the administrator of that directory. Actually, it says member, but I'm really administrator of that directory. And again, it's a free service. There's no cost behind using it. There are, however, Azure ADDS, Azure Active Directory services. That's a paid service. And there's also Azure AD Premium, which adds additional capability. That's also a paid service. Can we create a Spring Boot app for services as well? Yes, absolutely. Spring has a number of plugins to integrate with Azure. So you can create a Spring Boot app as a regular Java, EE, or a WAR type of application. Push that to Azure. Just make sure that when you select, when you define the web application, actually, let me just show you quickly. So there's my Contoso App Insurance Web. That's the one that I actually push from Visual Studio. You can see it's there, it's live. I should be able to open it, but it's not fully configured yet. But one of the things I would like to show you as soon as the UI comes up, under application settings, this is where I can choose which frameworks or programming language I want to use. Do you want to use .NET, PHP, Python, Java? So this is where I would select Java 7 or 8 over here. And if I select Java, now I can choose which version of Tomcat or Jetty do I want to host my application is. If you're doing a full-fledged Java EE application, then create an appropriate container for your application. So Wildfly, WebLogic, WebSphere, whatever you need. Take a look in the Azure Marketplace. You'll find some out there. I'll turn it off for now. So going back to that, yes, absolutely, Spring Boot works. I mean, table level metadata. Okay. My apologies, Diane. Oh, and unfortunately, Diane left us. But when it comes to that question, when I did the transfer from SSMS, that's when the data was transferred. The metadata, the structure of the database, the schema was created, then the data transferred over. So moving ahead. Sorry, just want to make sure I'm not missing. JSON Web Token. Okay, JWT. I'll have to take a look. I'm not sure if Azure supports JWT. I've never used it, so I can't comment. So just to answer the question for the both of us. Looks like you can, according to that website, looking at it quickly, but I'm not sure what's involved. Like I said, most of the work that I've done has been some SAML, but mostly OAuth 2. And yes, it would be different. Yeah, so I've seen the comment over here, OAuth 2 and JWT are definitely different. Can you compare using Azure and using Pivotal Cloud Foundry that also supports AWS deployment? Well, Cloud Foundry is there to allow you to provide a unified way to manage a cloud infrastructure, be it Azure or be it AWS or be it GCP. So the idea over here is you would create your environment in Cloud Foundry, and then you could use Azure to host your resource as opposed to AWT. So it wouldn't be a big change between the two. The only thing is Cloud Foundry would have to have the Azure adapters set up for that to work. And moving down, can we deploy microservices based on Docker containers? Absolutely. All right, full class support, first class support for Docker in Azure. Kubernetes is also supported. Docker Swarm is coming out if it's not already there, and other Docker containers. So it is fully supported. It also supports OpenID. Yes, absolutely. Thank you very much. And we want to deploy Docker containerized application on Azure. Absolutely. Actually, I ran a seminar similar to that. Actually, it was a workshop where that's all we did, talk about deploying Dockers and Kubernetes and pushing our recipes to Azure. So the short answer is absolutely. You can do that. You've got first-class support for Docker and various Docker technology in Azure. So is there still a plan for Microsoft for Azure on-prem? Yes, actually, that's a reality. It's called the Azure Hybrid, the Azure Stack. It is available. There's even a course for it. There's even a certification for it. It's been out either late last year, December, or early January this year. So Azure on-prem is available. Caveat, there's two versions. There's an SDK version, which you can install for testing and evaluation purpose. It requires a massive, massive machine. We're talking a machine with at least 6 CPU, each with 2 cores, if I remember correctly, at least about 100 gigs of RAM. So it requires a big, massive machine, 4 dedicated disks as well in the machine, and that's only to run the test version. For a prod version, you cannot use the software directly. You need to go to a vendor. You've got Levono, you've got Dell, you've got HP that all provide integrated Azure Stack. So Microsoft does not give you the ability to install the Azure Stack on-premise directly. You need to actually lease the machines from a certified vendor. So when it comes to that, Azure Stack vendor, just for the heck of it, there's more and more vendors being added continuously. Well, welcomes to new OEM. Or actually, let's just search for OEM. I should be able to find it faster. But going back to your question, yes, it is available. It's a slightly different beast than the Azure cloud. I mean, you'll recognize it. You've got the same Azure portal, most of the capabilities, but not all the capabilities are there. And of course, the administration now becomes very different, the behind the scenes stuff. But short answer, yes, absolutely. Is Azure Kubernetes service different than this PaaS? Well, Kubernetes is exposed as a PaaS. You could almost argue that it's an IaaS service, but personally, I see it more as a PaaS since you're not managing the machines directly. So yes, it is available as a PaaS for your Azure. All right, so I'm hoping I haven't missed any question. You guys ask a lot of really good questions in that presentation. I recognize I've already exceeded my time. It's 1:37 at least local time for me. I'm not kicking you guys out. If you have more questions for me, I'll stick around. I can do that. But I do want to say thank you very much for joining me for that seminar. I do appreciate that this has helped prepare you and arm you for your cloud migration, modernizing your applications. One last thing I'd like to maybe mention, if I can do a little bit of marketing while we're at it over here. For those of you who want more details in terms of anything we've looked at in this session, there's 3 courses I'd like to recommend. These are 3 Microsoft certified courses, and they're also certification courses for the developers amongst us. The 2532, Developing the Microsoft Azure Solution. Right? This course is for developers where we spend 5 days talking about doing what we've done plus more. There's also the Implementing Microsoft Azure Infrastructure Solution. So for those of us that are more infrastructure operation, this is the course to take. That's where we talk about things like managing VM, managing, say, load balancers for our VM, managing our virtual networks, managing the infrastructure for Azure, working with your ARM template. So again, 5-day course, it's a certification course. There's an exam accompanying it for those that are interested. And then for those that want to go to a level above, the Architecting Microsoft Azure Solution, the 2535. So this one is for architect, but I strongly recommend before you take the 535, take at least the 532 or the 533. This is a very in-depth course. It is not a high-level overview. We're not talking about creating simple visual diagram. We're going in-depth in how to architect things in Azure. Great course, but very much in-depth when it comes to that. I can also mention the 2537, since there was a question about Azure on-prem, the Azure Stack. The 2537 is not on the slide, but that's the course that deals with Azure Stack. It is, again, a 5-day course where all we do over here is talk about how to manage the Azure Stack on-premise. None of those courses have overlap or have very, very minimal overlap between the 3 of those. So it's not a question of which one well, it's not a question of, for example, the Azure Stack. If you don't know your Azure, you will struggle with the Azure Stack. Same thing with the 535. If you haven't taken the development or the infrastructure course, you will struggle with the 2535. So these are good, solid, in-depth course by Microsoft. These are not the only one, but for those that want to get serious with a facet of Azure, these are the ones I recognize. I'm seeing WS 2699. I'm not as familiar with the codes for web-based solutions, so I'll just look it up quickly for you. My apologies, I always go with the Microsoft course code. So WS 2699, just want to see which one that comes up with. Okay, so wait, that's not the one. Oh, so my apologies. I may not be talking about the same thing. Well, thank you very much for the feedback. WA 2699, but I'm not seeing it. Oh, actually, let's fix that. And okay, actually, that's a completely different one. This one touches a little bit on Azure, but it's not really an Azure course. It's a container course, a Docker course. But thank you for bringing it up. So that might be of interest. And I know you've asked a lot of great questions when it comes to Docker. So this one, if you want to talk Docker in the Windows world, that would be the course to take for sure. All right. So once again, thank you so much for taking the time to join me today. One last thing I'll leave you with. I recognize that, hey, there's a lot more we could have covered. You guys actually stuck around till the end, so I'll give you a bit of a bonus. Here's my email address. Bilodeau@chronogears.com. So if some of you have additional questions concerning what we've looked at over here, bring it up and come on. Boom, there we go. So if you have any further questions, you can drop an email. I'll do my best to answer them. Otherwise, I'll wind things down for that seminar. Hope you guys have a great evening. Hope you enjoy the weather. It looks a bit stormy here in Ottawa, but hoping that it's nice and not too hot wherever you are right now. Thank you for the feedback. And thank you very much again. Hope the same for you. Well, thank you very much, Al. All right, well, I do appreciate the positive feedback, but at this point, I will wrap things up with this seminar. So again, for those of you who are still online, thank you very much for joining. You have my email address. You also have your contact information for WebAge. If you guys have any questions, looking for assistance migrating your stuff or training, of course, contact WebAge, and we're here to help you guys. Otherwise, have yourselves a great evening, a great afternoon, and hopefully we'll see you again soon in another seminar or a training session.